So good morning, everyone. It's Feb 11th, CS 746. So first today, let us discuss a bit about the homework. Actually, the due date is on Feb 14th, but we are planning to change that. We are planning to change it to Monday instead of Friday. So this is a simple homework data cleaning that we discussed in the class. So you just need to load this error file and start cleaning. All the instructions are provided in this IP1B file. So if you open this file, you can find the instructions at the starting, and based on that instructions, you need to complete the homework. And you can compare the results with the original file. So this is the original file, so that you will understand like whether you are doing it right or wrong. And if you have any doubts, you can reach out to us in the Blackboard or in Teams. Okay, now just don't know why it's happening. One second. Okay, so today we are going to discuss about hypothesis testing, and this is the course outline. Okay, so we are at hypothesis and A by B testing. So let us start. One second. Sorry. Okay. So first of all, what is hypothesis? So in previous example, we discussed about there are two cases in hypothesis. So one is null and the another one is alternate. Like for example, let us consider one person hit the car and he went to the court, and the judge says, for example, the judge says he's guilty, but the actual thing is like the judge says he did the crime, and the real thing is he did the crime, right? So in that case, there is no error because the predicted value is the same and the actual value is same. But for example, he did the crime and the judge says he's innocent, then like you will get a type 1 error. Type 2, if the judge says, yeah, okay, yeah, okay, yeah, okay. So if the judge says he's innocent, but the actual thing is he did the crime, so it will comes under the type 2 error because there is a difference between the predicted value and the actual value. For example, the person did not do the crime and the judge says that he did not do the crime. So there will be no error because he's really innocent. So these are the type 1, type 2, and no error. And type 2 error, we call it as false positive, and type 1 error, we call it as false negative. So in previous class, we discussed about correlation. So in correlation, we check how one variable is varying with respect to another. Is correlation related to causation? Causation, in simple words, is nothing but if you change one variable, like is it really causing another variable to change? Like for example, if one variable is causing the another variable, then it refers to causation. But in correlation, we just discuss like one variable is varying with respect to another variable, but it doesn't mean that one variable is really causing the another variable. So correlation is not related to causation. And like for example, in court, there will be two lawyers. One is defense and another one is prosecutor, right? So like for example, if one did the crime and he went to the court, and there are two things, like the defense will consider that he is innocent, like he start with the point that he is innocent, but the prosecutor, he starts with the person did the crime. So the H naught in both the persons will be different. And coming to a null hypothesis, we will consider that nothing is happening. Like in previous classes, we discussed that if the new drug is changing the blood pressure. So if the drug that we discovered is not changing the blood pressure, then it comes the null hypothesis because it is not creating any changes in the blood pressure. But what is alternate hypothesis? So alternate is nothing but the drug is causing some change on the blood pressure, whether it is increasing or whether it is decreasing, but it is causing some changes. So in null hypothesis, there won't be any change. You just consider what is given. But in alternate, you are saying that like something is happening. So causation may happen in alternative hypothesis because like one thing is causing the another. But in null hypothesis, there is no causation. We just discuss what is given. And second, okay. So what is significance level? In previous classes, we discussed about alpha, which is a significance level. So we consider the null hypothesis H naught to be true until we find strong evidence against. Yes. So first, we will consider that drug is not causing any effect on the blood sugar. But if you want to say that the drug is really changing the blood pressure, you need to have a strong evidence. Without the strong evidence, you can't say that the drug is affecting the blood pressure. And once we find sufficient evidence, then we reject the null hypothesis. Yeah, if you find a point that the drug is really affecting the blood pressure, then you will reject the null hypothesis. This implies we accept the alternate hypothesis. Like when we reject the null, we accept the alternate. This does not prove H1 statistics is about proving. So in statistics, we basically discuss about the relationships, but it doesn't mean that one is really causing the another. Okay, because like for example, in the drug case, in null hypothesis, we will consider that the drug is not causing any effect on the blood sugar, and in alternate hypothesis, you will consider that the drug is affecting the blood pressure. That's all. But you are not explaining what making the drug, like what making the drug to cause some changes in the blood pressure. So you are not discussing about the scientific aspects like that are related to the drug. So in statistics, we just explain like there is no change and there is a change. That's all. We won't discuss the like what we can say the scientific details back in proving the alternate hypothesis. And sufficient is defined by significance level. So significance level is denoted by alpha, and the probability of type 1 error, if you choose smaller alpha, we require more evidence to reject H naught. Yes. So like if the alpha value is small, like if it is very small, then you need to provide more evidence to reject the H naught. And compare with the confidence level. Confidence level is nothing but 1 minus alpha, like how confident we are to found a real effect. Like, so in simple, it's nothing but if you want to prove something, so you need to be very confident in proving that thing. Like you need to show a strong evidence that the drug is affecting the blood sugar. I don't know why it's not working. Okay, so this is related to like comparing the population and the sample. In inferential statistics, we have hypothesis testing, so which is null and alternate. And this is done basically like to draw some like relationships in the population by comparing the sample. Because we can't take the entire population and do the analysis, right? We will take a little example, like we call it as a sample, and we make analysis on the sample, and based on the sample results, we will draw the conclusions for the population. Like for example, if we want to measure the height of every student in WSU, like we can't do that. So what we'll do, like we'll take a group of people, and whatever the like results that we get for that group of people will be given to that whole population. So truth about population, decision based on sample. So for example, if you observe this like matrix, null hypothesis and null. So like starting I explained the judge and the like the one who did the crime, right? So if there is a null hypothesis and you also proved that it is a null, so there is no error. And here, like in sample, you consider the null, but it came to be the alternate hypothesis in the population, which is a type 2 error. And the opposite, like you consider the alternate hypothesis for the sample, but it came to be the null for the population, so which is a type 1 error. And you consider the alternate for the sample, and it is also the alternate for the population. So then there is no error. So if there is a difference between the predicted value and the actual value, you will get error. If not, you won't get error. And there is some difference in errors. Like there are two errors. One is type 1 error and another is type 2 error. So these are a simple example of two types of error. So type 1 error, false positive. So the doctor is saying that for the man, he is pregnant. And for the type 2 error, if you observe, the woman is pregnant, but the doctor is saying she is not pregnant. So this comes under the type 1 error and type 2 error. Okay, I think that's all. Okay, so coming to some alpha values, in previous slides, we discussed about significance level, which is denoted by alpha. So let us discuss about some alpha values. Like if alpha equal to 10, we can expect to be wrong about one time in 10. For example, if you toss a coin 10 times, there is a chance that you can be wrong only one time if alpha equal to 10. So be wrong means here type 1 error. So incorrectly reject the null hypothesis. So at alpha equal to 10, we have 90% confidence interval. And at 90% confidence interval, we have the sigma values as 1.28 and 1.645. And coming to alpha equal to 5%, there is a chance that we can be wrong about one time in 20 compared to 10 for alpha equal to 10. And when alpha equal to 5%, it is 95% confidence interval, and the sigma values are 1.645 and 1.96. And when alpha equal to 1%, like there is a chance that we can expect to be wrong about one time in 100. And if alpha equal to 1%, it comes under 99% confidence interval, and those are the alpha values 2.326 and 2.576. For example, if alpha equal to 50%, when we toss a coin, there is a chance of 50% whether you can get a head or a tail. So it comes under alpha equal to 50%, and those are the sigma values. If alpha equal to 50%, there is 50% confidence interval, and the alpha, like the sigma values are like 0 and 0.674. And if alpha equal to, if you observe that 0.0006, like we are high energy physicist with a real expensive machine. So if alpha equal to 0.000 something 6, like it comes under 99.999 confidence interval, so which is 5 sigma. So this is in simple based on confidence intervals, like there will be alpha values. So you will decide the significance of the values based upon these. And okay, so this graph we discussed in previous classes. So mu will be the mean, and mu plus sigma and mu minus sigma will be the first standard deviation. And mu plus 2 sigma and mu minus 2 sigma will be the second standard deviation. So standard deviation will explains like how far your data points from the mean. And if you observe the middle part, which is 68.23, this 68.23, so it comes under the first standard deviation. So in first standard deviation, we can cover 68.27% of the values. But coming to the second standard deviation, it is 95.45%. And coming to the third standard deviation, we cover 99.73%. So if you consider the third deviation, we have like more, like 99.73% of the values. Okay. So at 90% confidence interval, we have, see, if you observe the confidence interval, when it is 90, we have alpha equal to 10% on both the sides. When the confidence interval is 95%, we have alpha values as like 2.5% and 2.5%, so which is 5% in total. So if you consider 100%, we have like 95% confidence intervals, and the alpha values will fall the remaining 5%. And coming to the, if you observe 95.45%, which comes under the two standard deviations, and coming to the 99%, so there is only 1% of alpha value. So here we will get like 1% 0.5% on other side and 0.5% on the other side. So this is how a normal distribution, like this is how the values are divided in if you compare a normal distribution. So now let us discuss about population and sample. Population is nothing but you are considering all possible samples. Like I said before, if you want to measure the height of the entire people in the university. So what comes under the population? You are considering all people in the WSU. So those comes under the population. And coming to the sample, you will select only a specific people or a group of people, and which comes under the sample. So this is in simple, like all internet users. So it comes under the population. But if you consider people who visit the website, like who visit WSU, so which can consider as a sample. Okay, what are the steps to perform hypothesis testing? So first, you need to select what is null and what is alternate, and you need to set the significance level, and you need to compute the test statistics. There are actually two. One is Z and one is T. Basically, we will consider two, but there are like many. And you need to make a decision, like based upon the values you consider. So these are the steps to perform hypothesis testing. One is you need to state the first you need to state the hypothesis, and you need to set the level of significance as a step two, which is alpha, and you need to compute the test, like the test will be performed on the sample because that is what we considered from the population, and you need to make a decision based upon the p-value. So if p-value is less than alpha, so we reject the null, and if the p-value is greater than alpha, we fail to reject the null. So if we fail to reject the null, we simply accept the alternate. So based upon the p-value, you will make the final decision whether you need to reject the null or whether you need to accept the null. So this we also discussed in the previous. So if you observe the p-value, so this is the p-value, and like the values that fall here, like which are greater than these, it comes under the rejection zone, and whatever the values that falls under the less than, like if p is less than the alpha, we reject the null, right? So whatever the values that are fall in like less than p, it comes under the acceptance zone. So this is the rejection zone, and this is the critical value. So if test statistics, whether it can be a Z test or T test, if it is greater than critical value, then we reject the null. And this is just explaining this graph, like alpha is the area of the critical region and p-value is the area to the right of the test. And when test statistics in critical region, like p-value is less than alpha, and we reject the H naught. So this is just explaining like which region you need to accept and which region you need to you need to reject based upon the p-values. So what is the p-value? So it is a probability value. It is a probability value, and how likely it is to see your data. The likelihood of seeing your test statistics, like for example, we basically decide which values to accept based upon the test statistics. For example, if p-value is equal to likelihood of seeing a result as extreme or more extreme, then the one calculated by your statistical test. So assuming the null hypothesis is true. So in simple, like if p-value is less than alpha, we reject the null. If not, we won't reject the null and we accept the alternate. So that is what this slide explains. It's taking so much time. So p-values and statistical significance. So p-values are most often used by the researchers to say whether a certain pattern they have measured is statistically significant. So as we are accepting the null or rejecting the null based upon p-values, right? So p-values are most significant. So how this is gonna help in your projects? Like for example, maybe tomorrow, I think you will get your data sets. So you will clean the data based upon the like based upon the code that we discussed. And after that, once you observe all the relations in your data, you will start building the model. And you will decide like which variables I need to consider for my target variable. So based upon the p-values, you will decide, okay, these variables are significant and these variables I need to use in my model, and the remaining variables I need to, like, I just simply ignore those variables. So at that time, this concept will be useful in, in deciding which variables you need to use in your projects, like in your model building. These concepts you'll understand like when you are at the stage of model building. So you need not to worry if you didn't understand anything, it's fine. And the p-value can only tell you whether or not the null hypothesis supported, as I discussed. In statistics, we basically like won't discuss like what is causing the things. Like I said, the drug is showing some effect on the blood sugar, right? But we are not discussing what making the drug to increase or decrease the blood sugar. So we will just decide whether to reject the null or whether we need to accept the alternate based upon the p-values. That's all. So it cannot tell you whether your alternate hypothesis is true or why. Yeah. So we won't discuss why it's happening. We will discuss, okay, it's happening. That's all. And okay, so we could accept or reject H naught based upon the test scores and critical value. And so why we need to use the p-value? We only need one value to make a decision about a hypothesis. So we are making our decision whether to accept the null or whether we need to reject the null based on p-value, right? So we are using only one single value. And we don't need to compute two different values like critical value and test scores. Yeah. So for example, if you consider like test scores and critical value for deciding whether you need to accept the null or whether you need to reject the null. So instead of two different values, if there is a single value, it will be easy in order to make a decision. So that is the reason we are using the p-values. And we can test at any desired level of significance by comparing this directly with the significance level. Like for example, if we design an experiment with the significance of 0.05 and we get a p-value 0.004. So this is a significance exceeding alpha equal to 0.1. So here it's 0.05 and the p-value is 0.004, so which is less than the significance level. So in your variables, when you see the p-values like at the time of model building, you will observe such kind of values, like your p-value will be 0.000 and the alpha value will be 0.05, and sometimes the p-value can be 0.06. At that time you won't reject the null, you will accept the, like you will accept null, right? Yeah. So based upon the values, you will simply decide which variables are important or which variables are not. So there are different type of hypotheses we consider. For example, this is directional. There is an example considering female will score significantly higher than males. So that this is called a one-tailed, because we are considering only the one part of the rejection region. But if you see the second one, there are two on both sides. So it is non-directional. Like for example, if you consider female will score significantly different than males on IQ score. So in two-tailed test, we will consider both the rejection regions, but in non-directional, we will consider only one. So coming to Z, okay. So we discussed about significance level alpha and different type of alpha values. And coming to the test, there are basically two. One is Z test and one is T test. So in Z test, we know the population variance. So you consider all the people in the WSU and you know the the variance of the population. And we do not know the population variance, but our sample size is large. So you consider the population and also you consider the sample. And if your sample size is greater than or equal to 30, then we are going to use Z test. And if it is less than 30, you will use T test. Z is used to signify normal distribution. If you have a sample size of less than 30 and do not know population variance, then we must use a T test. So there are only two things. First, if you know the population variance, for example, you consider the population and you know the variance of the population, and your sample size is greater than or equal to 30, then you are going to use z-test. In t-test, okay, so in t-test, we do not know the population variance. So if you don't know the population variance and your sample size is less than 30, then you are going to use the t-test. So next one second. That is a simple example. Coming to, okay. So you will prefer other tests, like for example, there is chi-square test, like there are different type of tests. I uploaded one statistical tables PDF to the Blackboard, so where you can observe like different type of test compared to Z, T and chi-square. So those are basically preferred, like if your sample size is very low, like what happens if your sample size is not greater than 30 or it is like very less than 30, then you will prefer other tests, and those are some of the other tests. And okay, so this is the comparison for the t-test and the z-test as we discussed. So if the variance is not given, you are going to use the t-test and the sample size is very small, like the small, and z-test is the, if you know the population variance and if your sample size is large, then you are going to use the z-test. So this is the t distribution. Okay, so this is the t distribution and this is with degrees of freedom. So what do you mean by degrees of freedom? Like the variable has like freedom to change. So if you observe this graph, there are different t values, like t with 10 degrees of freedom, t with 2 degrees of freedom, t with 1 degree of freedom. But they are in the same shape and they are fall in the same region. So in degrees of freedom, even though there is a freedom for the variables to change, they all fall at the same place. So if you observe green, orange, blue, and pink, even though there are different values, the mean will falls at the same place. So that is what the degree of freedom means. Okay, t distribution versus normal distribution. So t distribution is defined by its degree of freedom, as we discussed before. So the variables have the like freedom to change, but they all fall at the same place. So these are related to the sample size. The t distribution is most useful for small sample sizes. So we are going to use t-test when the sample size is small and when the population standard deviation is not known. So population variance, so variance is nothing but the square of the standard deviation. So when you don't know the standard deviation of the population, you are going to use t-test. And as the sample size increases, the t distribution becomes more similar to the normal. So then it comes the z-test. So degrees of freedom. So degrees of freedom is defined as n minus 1 because n will be the population, like n will be the number of samples in the population. But if you consider the sample as we are taking, like for example, one sample, then the degrees of freedom will be n minus 1. So we are removing the sample from the whole. So that is the reason it is n minus 1. We want to test if our sample mean is equal to our population mean. So we are doing analysis on the sample and based upon that, we will make analysis for the population, right? So like how we are going to do that? So first we will analyze the sample mean, whether it is equal to the population mean. And if we run the experiment multiple times, we get different data points. So the given mean of the data we collected, like how many of our data points could have varied? Answer is all but one. So the thing is, if you run the experiment multiple times, you will get different data points, right? So the mean of the data like we collected. So the thing is, if you run the experiment like multiple times, you will get the data points at different places. And if you observe the mean, we can observe like how your mean is changing from the sample compared to the population. And in order to get the same mean, one sample value is constrained by the another n minus 1 values. So this is in simple. For the like population, there are like n, and you are removing the sample from the whole population, which is like n minus 1, and that is the reason for the degrees of freedom we use n minus 1. And next, t distribution versus normal distribution. Okay. T distribution has smooth shape and it is symmetric. It has the mean of 0. Unlike the normal distribution, the t distribution does not assume that the population standard deviation is known. Yeah, in t distribution, the standard deviation of the population is unknown. If it is known, then it is mostly like normal distribution, and we are going to calculate the Z test, like not the t test. So this is like how the t distribution with 30 degrees of freedom. So it is simply like the normal distribution. So these are some of the references for the lecture that we discussed now. So this I will explain later, because today we are going to discuss about hypothesis and also the example and also A by B testing. This I will explain at the end of A by B testing. And okay, I will stop recording.